Hello again, everybody, and welcome to the fourth video in our measurement series. Today we're going to look at the volume of right pyramids and right cones. Let's review what volume is. Volume is the amount of space an object occupies. It's measured in cubic units. Another way to think of volume is the amount of liquid that would fit within the shape. We're going to look at two shapes today, right pyramid and the right cone. So the formula for your right pyramid is as follows. It's equal to the base area times the height divided by 3. Now, if you remember the surface area of a right pyramids can look a bunch of different ways. The base of the pyramid is actually what controls the naming of the pyramid. So that's why I have to give you something general like base area. So for the example I have here, this pyramid, I would have something more like I could kind of tailor my example, or sorry, my formula, and that is a rectangle. So I can go, well, the base would be really length times width, and then it would be times my height, and divided by 3. So this part here will change kind of depending on the pyramid, but in general, we'll just follow this form. It's not as specific a formula you may be used to, but I'll be giving you a specific formula for the cone. All right, so right cone volume formula. You can see it's right here. The volume of a cone is equal to pi times r squared times h divided by 3. Pi, 3.14. R squared, remember r is your radius, and the h is the height of the cone. Reminder that cones also have a slant height, so that could come into play sometime as well. All right, first example. Let's check out the volume of this pyramid here. So, go to my blue pen. Volume is equal to that base area. I'll just say BA times height divided by 3. The base area, well, it's a rectangle again. So really, I'm just going to go 5.4 times 3.2 times my height, which I was given, 8.1. If you're not given the height, what they may do, everybody, I'm just going to add this to my drawing. Maybe I'll put this in yellow. Remember, there's such thing as a slant height in a pyramid as well. So sometimes they'll give you the slant height and they won't give you the height, and then you have to use your Pythagoras triangle to figure out that's the actual height. Anyway, back to my calculation. This whole thing divided by 3. When I multiply those together, I would get 139.968. Divide that by 3. I'm going to get 46.656. Now, I didn't stress where we should round to. So for this one, we'll just say tenths. And you want to pay attention to your question. It'll state what it wants. So if it's tenths, then it would be 46.7. And what are we dealing with? We are dealing with centimeters cubed. Volume is always a cubic measurement. So centimeters cubed. Remember, if this would have been inches, we'd have to write actually cubic inches. I know we've talked about this in a previous video, but just that in imperial, with imperial units, you'll put cubic first. With metric units, you'd put it last. Let's move on to the next example. All right, so another pyramid. I'm going to check out the base. Again, it's rectangular. So we'll work on this real quick. The volume is, again, this base area, I'll change it to a capital BA times my height divided by 3. My base area would be 7.2 times 4.7 times that height, which again, I'm given the height in this one, so no big deal. Divide that whole thing by 3. Multiply that, I get 267.336. Divide that by 3. 89.112. And if I said hundredths for this one, which I'm being lazy and writing hundredths, no judging, I would get then 89.1. And then just remember, you have to look at the digit that comes after the digit you're really rounding to. So I'm rounding to the second decimal place, but I have to look at that too. It's between 0 and 4, meaning I'm going to leave that as 1, 1. And this would be cubic inches. Okay, so in both these two first examples, we had rectangular bases. The textbook that we're using, we're not going to have any crazy bases like pentagons or anything like that. But yeah, it would get more complicated possibly to find that base area. We'll look at some square bases here next. So how do I know this is square? Well, in this diagram I drew, I only listed the one measurement on the base, which is 4 inches. And I don't list another one. So if they don't list another one, you can assume that they're all the same length. All right, so go to my formula. Volume is going to be equal to this base area times height. Base area kind of sounds funny. Area of the base might be a bit more meaningful to you. So area of the base times the height. The area of the base, it's a square, so depends how you want to do it. I can just still go, though, 4 times 4, really like a length times width. I could have wrote 4 squared, whatever I want to do. And then, if you look, I don't have the height. My height would be right here. I was given a slant height, so I'll have to do some other work to figure that out. So let's change colors. I'll change it to green where I'm doing this. What I suggest doing is when you're trying to find the height and you're given the slant height, I like to draw out my right triangle that is within this pyramid here. So my slant height is 6. I'm looking for my height. I'll call that x. So that means I need to know that bottom length. So the bottom length. What we have to remember is the height, if you go back to the triangle or the pyramid, the height is always comes straight down to the center. Meaning, if I draw this out, this segment would equal this segment. So this would be 2 and that would be 2. So I know the bottom of my triangle would be 2. Now I can go forward here and just solve for my height. Sorry, I'm tripping over my words there. So I would get x squared plus 2 squared equals 6 squared. And just work it through. X squared plus 4 equals 36. Subtract 4, subtract 4. X squared equals 32, and then x equals, and we're going to take it down to a number, to a decimal. We're not going to leave it in radical form. So 5.65, and then I can go back over here. 5.65. I found that height and divided it by 3. When I multiply 4 times 4 times that 5.65, I get 90.4. Divide that by 3. I get 30. And we'll go to tenths again. 30.1. And that is cubic inches. All right, so this question was similar, but there were some differences. First difference, the base was a square, not a rectangle. Really, that did not affect us at all. The main difference was they gave us a slant height, not the height. We had to find the height, but to find the height, you always just use Pythagoras, so truly it's not a big deal either. By the way, that was a pretty awesome circle. Look at, you can't even tell where I started or stopped that circle. Amazing. You just witnessed history. D, let's look at one more. Again, it's a square base, and this diagram may be tough to look at here. Whoops. There we go. My pen wasn't working for a second. But that is a slant height they're giving us. And the way I know that is I can see that I'm going to scratch that out. The dotted line comes down to the perimeter of that square, not the center of that square. So that's how I know that's a slant height. Sometimes these three-dimensional drawings on a two-dimensional space, like sometimes they're kind of tough to understand or comprehend. So just wanted to point that out. Again, I'm going to start my question just like I always do. So this is the area of the base, or base area, times my height divided by 3. My base is going to be 2 times 2. So just like the previous example, I only listed one dimension, 2 feet. I don't list anything else, so I have to assume that they're all 2 feet. My height is what I have to find, and then I'll divide that by 3. So again, I'm suggesting draw the little Pythagoras triangle, the right triangle on the side. It doesn't need to be proportional. I know my slant height is 7. I'm looking for my actual height. And then this 2 feet, again, the height or the slant height of that triangle, it always comes down in the center of the side, of that side. So meaning I know it's going to be 2 and 2. So you don't have to worry that when you have a square base like this, on a right triangle, a right pyramid like this, You don't have to worry about that being like, say, 3 and 1. It'll always be even, like cuts it in half. So 2 and 2. So anyway, there's my 2. And here I go. Just going to now use Pythagorean theorem to work it out. Not much to talk about. Just working it out. So I get 45, and then I got to figure out the square root of 45. 6.7. And then I can put my 6.7 here. So really, you can take as many decimals as you wish. Like if you work this out, you'll see that you actually get a lot there. So I'm going to take one more decimal, 7.1. Really take as many as you would like. More is always better. Now, once I've got all my dimensions kind of written down, now I'm just going to multiply this out. So 2 times 2 times that 6.71 gives me 26.84. Divide that by 3. I'm going to answer the nearest tenths again, everybody. I would get 8.9. 8.9. And that would be cubic feet. Okay, so I think we've covered pyramids pretty well. Let's now start to focus on cones. So here you can see is a cone. One thing about this cone, or again, we should likely write down the formula for a cone. The volume formula for this cone. Where shall I write this? Volume is equal to pi r squared h divided by 3. So that is the formula that we will use for this. I can't remember if I wrote that down previously, but here it is now, okay? So you need that radius, and you need the height. All right, so I have my height here. The height was given here, but this is my radius. What they've given me right now is a diameter. So I need to figure out my radius. Remember that the radius is equal to your diameter divided by 2. So 12 divided by 2 equals 6. You're right, you likely didn't need to write this out to show it, so if you don't want to do that, you don't have to. But now I know my radius is 6, and like I said, my height was 18. So I can just get into solving this. So volume equals pi r squared h divided by 3. You can use 3.14, you can use actually the pi button on your calculator. It won't matter when you're working with your textbook, use one or the other. 6 squared, my height is 18, divided by 3. So 3.14 times 36, because 6 squared is 36, times 18 divided by 3. All right, so that top works out to 2034.72, and then divided by 3. And when I divide that by 3, I get 678.24. I'll take it to hundredths. And that would be cubic inches. Again, if you watch or look for the details in the question, your question will clearly state if it's tenths, hundredths, or whatever you're supposed to round things to. But back to this question, yeah, so there is your right cone. Right cones, they only ever look one way, so that's why we get this very particular formula. Pretty easy to work with, right? So our final example, volume is equal to pi r squared times h divided by 3, r being radius, h being height. And I can see that I'm given both of these. Again, the one kind of add-on with this question is, remember, there's my slant height. So they may give you a slant height and you have to find the height. If that's the case, it's just like the pyramid examples I've done, so there's nothing different about that. So let's get right to everything here. So 3.14, my radius is 4, my height is 13, divided by 3, 163.28, divide that by 3. We'll go tenths again, 54.4, and that is millimeters cubed. Again, notice that with metric you put the cube after the unit. Imperial, you put the cube before the unit. Okay guys, well that is everything I have for you. Again, pyramids can look a bunch of different ways, therefore we don't have a nice Easy formula, we have more of a general outline. Cones, they only ever look one way, so we do have a nice easy formula for it. I hope it made sense. If it didn't, make sure you talk to your teacher. And otherwise, have a great night, everybody.